Okay, let's take a look at how you did with these. The top one up there. Obviously, we have to do the parentheses first. In there, of course, we have to multiply. 1 and 7/8 times 1 and 3/5. What does that become? 15/8 times 8/5, which ends up giving us just, yeah, well, it ends up being actually 3. Yeah, the 8's cross cancel, give me 1, 1, 3, and 5. So it's just 3. Right? So that's all gone. That's just 3. How do we do a mixed number minus a whole number? 4 and 1/3 minus 3. Well, is there anything to take away from the 3? No, or the 1/3, I should say. No, the 1/3's there. 4 minus 3 is 1. That's just 1 and 1/3.
What if it was 1/3 minus 3?
Then you'd have to go negative. It was just 1/3 minus 3, like that.
Yeah.
So then what you do is, there's 1/3 minus 3. It's going to go on the negative side.
Right.
So then you'd have to switch it around to 3 minus 1/3, and the answer would be negative.
Okay.
So it'd be a negative 2 and 2/3. The one that's actually more difficult is if it were like 5 minus 2 1/3. Well, now what do I take the 1/3 from? Well, it's just like if you had a decimal, you put 0.0 after it. Well, this is going to be 0/3. And then you have to borrow. So this would be 4 plus 3 is 3/3. So it's 2/3 and 2. So now we've reduced everything in the parentheses to a single number. I can get rid of my parentheses. Put in my multiplication up there. What's next? Multiply 1 1/2 times 1 1/3. So this will be 3/2 times 4/3, which is 2, right? 2 and 4 cross cancel, give me 1 and 2. 3 and 3 cross cancel, give me 1 and 1. That ends up being just 2. So I just put 2 in there. So now I've got 2 and 3/8 plus 2 is 4 and 3/8. Plus or minus, my 1 and 1/3. Common denominator is 24. So this will be 9 24ths. This will be 8 24ths. So I subtract, I've got 1 24th, 3 and 1 24th. Anybody get that? Do you have any major questions on where that came from? Okay. On top here, 2 1/4 times 3 and 1/3. Well, that's 2 times 4 is 8 plus 1 is 9/4. 3 times 3 is 9 plus 1 is 10/3. So 9 and 3 cross cancel, give me 1 and 3. 4 and 10, give me 2 and 5. 3 times 5 is 15. 2 times 1 is 2. So on top, I've got 15 over 2. I'm going to leave it as an improper fraction because I know I'm going to have to divide it by something, and I have to have it as an improper fraction to divide. So on bottom, 3 1/2 plus 1 and 3/8. I'll change that to 3 and 4/8 plus 1 and 3/8. 4/8 is just 1/2 turned to 8s. So now 4/8 and 3/8 is 7/8. 3 and 1 is 4. So I have 4 and 7/8 here. So I've got 15 halves divided by 4 and 7/8. So 4 times 8 is 32 plus 7 is 39/8. So this becomes 15 halves times 8 over 39. 2 and 8 cross cancel, give me 4 and 1. 15 times 4 is 60. 1 times 39 is 39. So that is 1 and 21 39ths. What do you think? More fun than a sharp stick in the eye? For now? I probably shouldn't say that with you. You had the eye problem. This is a little sensitive. So, next time I'll say more fun.
You said it yesterday too. I didn't even catch it.
Yeah. I didn't even realize that. It's like, oh, wait a second. From now on, it'll be more fun than a large bug in the eye. How's that? You just became famous. You'll
Yeah.
be recorded for
That's right.
all eternity. Okay, so on the homework, page 76, was it 2 or 3 that you're having trouble with? Is it number 2 or 3 there that you're having trouble with? 3?
Exercise 218.
What's that?
Exercise 218.
218, yeah, which number? 1 or 3 or?
1 through 3.
1 through 3? Okay. Number 1 is a horsepower formula. So the horsepower is determined by 2 times pi, which is a decimal, times T, which is our torque, times R, which is our RPM per minute, over 33,000. 33,000 is just a conversion rate for horsepower. This is rotary horsepower, that's why there's pi in there. And what they want us to do then is over in that little table, A says that the torque is 3.5, and our revolutions per minute is 2250. So this becomes 2 times pi times T is going to be replaced with 3.5, and revolutions per minute is going to be 2250. The problem is here, what's that? Well, we haven't done over that. It is a decimal. We use 3.14 for it. But we haven't done decimals yet, so how do we mix our decimals? Did they give you a... Oh, they just 3 1/7. Okay, perfect. Thank you. So they're listing it as 3 1/7. So now we can use it as a fraction. Oops. What's that? Apparently. Well, 22 over 7 is a lot more accurate estimate of pi than 3.14.
Right.
So, first thing we have to do there is we have to do the 2 times 3 1/7. So that's 2 over 1. 3 times 7 is 21, plus 1 is 22 over 7. So that's 44 over 7. So we've got the 44. I'm going to leave it as an improper fraction. Times 3.5 is next. So 3 times 2 is 6, plus 1 is 7 over 2. So the 7s cancel out, give me 1 and 1. 2 and 44 cancel out, give me 22 and 1. So that's just 22 to here. So now all we have is 22 times 2,250, and then divided by 33,000. So 22 times 2250, and then divided by 33,123. Now it's going to give it to us as a decimal, 1.5. That we can see and know that it's 1.5. But if we didn't, we'd do this. We'd write down the whole number. Then we'd subtract the 1 from it. Then we got to figure out what do we do to make that 0.5 into a decimal. Most of your calculators have an FD key like that. So if you hit that, you can turn it into a fraction. The Casios or Sharps sometimes don't have that. The Texas Instruments will do that really well. It's usually up towards the top left side. Yeah, it's usually up above one of your keys. So you get 1.5. If you just left it as 1.5, I'd be okay with that. Okay. We're going to call that good for now. Actually, I should do number 3, shouldn't I? On the job, 3 carpenters, each working 5 1/4 hours. So that's 5 1/4 times 3. There's 3 of them. 4 others, each work 6 1/5. So that's times 4. And 8 others, each work 7 1/3. So 7 1/3 times 8. So now we have to multiply this out. 5 1/4, that's 21 over 4. Times 3, so that's 63 over 4. Or 15 3/4. 6 1/5, well 6 1/5 is going to be 31/5 times 4 over 1. It's 124, not 128. 124 over 5, which is 24 and 4/5. 7 and 1/3. 7 times 3 is 21, plus 1 is 22 over 3, times 8 over 1. That's 176 over 3, which is 65 and 1/3. Then we got to add all those up. Common denominator, what, 60? Looks like. So it's 4 times 15, so 3 times 15 is 45. 5 times 12, so 4 times 12 is 48. 3 times 20, so 1 times 20 is 20.
Except the bottom one says 58 and 2/3. 176 over 3.
Is that 58? Oh, shoot, you're right. Thank you. Yeah, I missed that one by a ways. So this is 58, and this is going to be 40 then. So 3 times 20, so 2 times 20 is 40. So that adds up to, what, 133/60ths? So that is carry the 2 and keep 13/60ths. If it goes in there 120, it'd be twice with 13 left over. So that's 7, 11, 19. So 9, carry the 1, 2, 4, 9. So 99 and 13/60ths would be our answer. I won't be quite that cruel to you on a test or quiz. Any other questions off the homework? There are some of you still working on the quiz, and that's fine. Please take as much time to finish as you need. I'm going to go ahead and start on our new topic here quick. What we're going to look at today is we're going to start looking at decimals. And decimals, to understand decimals, it requires us to go back and look at our place values some more. You know, this, of course, was the ones, tens, hundreds, and so on. 1,000s, 10,000s, and on up. Well, I'm going to write them this way. I'm going to put in a numerical value. So just 1, 10, 100, 1,000, 10,000, and on up. And as we look at this, as we move one notch to the right or left, let's actually move to the right. If we move one notch to the right, what happens to the numerical place value? It's divided by 10, right? Move one notch, divides by 10. Move another notch, divides by 10. So if we were to keep going here, past the decimal point, we'd have to do 1 divided by 10, which would be 1/10. 1/10 divided by 10 would make this the 1/100th. Divided by 10, that's the 1/1000th. And 1/10,000th. And so on. Now, I get the question all the time, why isn't there a 1ths place after the decimal point? Well, it's exactly because of this reason. You have to divide by 10 as you go. Well, 1 over 1 is just 1, so there is no fraction that represents that. Looking at these place values, some of you might be thinking, well, they look suspiciously like fractions. And they do. They are fractions. Decimals are nothing more than a short way of writing very, very specific fractions. Fractions that have denominators that are powers of 10. For example, if I have 0.64, all that is a shortcut way of writing the fraction 64/100ths. You'll notice the denominator is the place value of the last digit, last non-zero digit, if you will. So if I have 0.135, that is 135 thousandths. A little trick, by the way, rather than having to count out tenths, hundredths, thousandths, there's 1, 2, 3 decimal places, 1, 2, 3 zeros in our denominator. Now, either one of these fractions right now, I would not leave the way they are. I would convert them or I'd reduce them. This one here can both be divided by what? 2. Giving me 32 over 50. I'd still go by 2. Giving me 16 over 25. So 0.64 is 16/25. This one here, of course, can be reduced by 5. Giving me 27, right? Over 200. What if there's a whole number on the beginning of it? Something like this. Well, what's in front of the decimal point does not affect what comes after it. This is just a mixed number. What's in front of the decimal point is our whole number, so that's just 5. The only part that's in a fraction is what's after the decimal point. So the 0.648 is going to be 648 over 1,000. Good. Tenths, hundredths, thousandths. Again, 3 decimal places, 3 zeros. Now, of course, this can be reduced. Those can both be divided by, let's try 4. What's that give us? What's that? 162, right? Over 250. Are we done? No, both of those can still be divided by 2. Give me 81 over 125. Are we done? Say no. What am I forgetting? Gotta remember the whole number. 5 and 81 over 125. When you reduce something like that, that's the biggest mistake I'll see people make, is they'll forget to go back and put the whole number on it when they're done. In your notes, see if you can turn that into a fraction and reduce it. So this is going to become 625 over 10,000. Good. 4 decimal places, so 4 zeros. Reduced by 5 works. 625 divided by 5 is what? 125. 10,000 divided by 5 is 2,000. Still reduced by 5. Gives us 25 over 400. Still reduced by 5. Gives us 5 over 80. Everybody get 5 over 80? That's it.
1 over 80. 125 divided by 5 is 5.
125 divided by 5 is 25, right?
Yeah.
Yeah. If you divide by 25, would give you 5. So 5 over 8 or 1/16, right? Okay. You look confused. You divided one by 25 and the other one by 5. So your first step, you divided each by 5, or did you divide by 25 first? So that should give you 125 over 2,000, right? So that should give you 5 over 80. Okay. The good news is I'm not going to give you any new homework today. Bad news is there might be another quiz tomorrow. There might be another quiz.
Will you have this quiz tomorrow?
I should have this graded and back to you tomorrow when you come in, yes.